Okay, we did direct variation already, but we only spent 1 day on it. We didn't have a whole lot of practice on it. There was a question on the quiz on it, and we're going to go over that today. And then we're also going to add indirect variation. Okay, direct variation. Do you guys remember anything about direct variation? Okay, it is. We did a whole set of problems on it in the book last week, last week. Yes, you can solve it with a proportion. Sometimes it says directly proportional, directly related, directly varies. That's all the same thing. Okay, now it is linear. Direct variation is linear. Indirect is not, by the way, but direct variation is linear. And one of the facts that's nice about it is it has to go through the origin. Remember these? Which makes it a very easy line, because what is one of your points always going to be? 0, 0. What's the y-intercept always going to be? 0. Okay, so we don't have to worry about finding the y-intercept. It's always going to be 0. And finding the slope is super easy. Normally, to find slope, you've got to do y minus y over x minus x. You don't have to do that on direct variation. Why not? Because one of your points is always 0, 0. So if you subtract 0 from the y number and subtract 0 from the x number, is that going to affect anything at all? No, so guess how many points you need to find the entire equation? Just one. Because once you know the slope, by doing y divided by x, you can skip the subtracting part. The y-intercept you already know, it's 0. So that's what made these easy. Now, we did problems, but we set it up like proportions. You can solve problems that are direct variation in a proportion, or you can make a line out of it and solve it like a linear function. Now, the trick is you have to understand when they give you a point, you have to make sure you correctly identify what's independent and correctly identify what's dependent. And sometimes that can be a little tricky. And they also give slope a special name. They call it K instead of M. And the reason why they do that is because it's a special kind of line. It's the one kind of slope that you don't need 2 points to find. Technically, you already know one of the points is 0, 0. Okay, so let's look at a couple of questions about direct variation. This one should look familiar to you. It's from the quiz you just took. Now, there's lots and lots and lots of different ways to do this. Some kids were able to make a proportion out of it and it made sense to them and that worked. I just turned it into a linear problem. Do they give me a point? They absolutely give me a point. They flat out tell me what y equals and what x equals. What does x equal? 30. What does y equal? 20 over 3. What other point do I know has to be on this if it varies directly? 0, 0. Where can you go if you know 2 points on a line? Stat edit, stat calculate. This is the one you missed, Nicole. Do that right now. Stat edit, stat calculate, and tell me what it says. It's going to give you a slope that's a decimal. Of course, these choices are in fraction form, but you just have to convert it. You had to remember, direct variation, I know 0, 0 is on it. Then you had to pick out the point they gave you. They gave you the y number first and the x number second. You just had to kind of rewrite it. And then you have to know how to find a linear function in your calculator. It should tell you that the y-intercept is 0 and that the slope is 0.2 repeating. What fraction up here equals 0.2 repeating? 2/9. So this was a super easy question. No, this is a gift. You should not miss one like this. Did anybody do it? Yeah, some kids set it up like a proportion, which would work. Some kids just checked the answer choices. They put in y equals 200x, looked at the t-chart, and they were looking for 30, 20 over 3, and it wasn't there. Then they went to y equals 2/9x, checked the t-chart. Guess what? It was there. And of course, it didn't say 20 over 3. It said 6.6 repeating. Or you had to know that that's 20 over 3. You could also do this. I'm going to plug a 30 into the problems and see which one gives me back the right y value. If I put a 30 in here, what do I get back for y? 6,000. That's not even close to 20/3. Look what happens when I put a 30 in here. 2/9 times 30. That's going to be 60/9. Guess what 60 over 9 reduces to? 20 over 3. That's the winner. That's the only one where the point works. So many ways to do it and or check it. Here was another direct variation problem that was on the test several years ago. Please look at this and try it. Let me just tell you, when this was the actual test question, I would say about 40% of all the 8th graders across the state picked the same wrong answer. And that's a clue that we as teachers need to make sure we go back and talk about why they liked the wrong answer. Because there was a lot of kids that liked the same wrong thing. It was the best wrong answer, yes. One thing I meant to remind you about a second ago when we were first reviewing direct variation, and I just heard Jair say it. What did you say? X is not on the bottom. On a linear situation, if it's direct variation, X cannot be on the bottom. That's one thing you got to know. Not if it's direct variation. So which ones should we be able to eliminate right away? Because look, see how they have X on the bottom? But the same wrong answer that kids really liked was C. A lot of kids picked C, and it's wrong. But something about C is correct. The slope part is correct. Now, you had to understand, they're giving us a point, but they don't come out and tell you, hey, X is this and Y is this. They tell you 5 pieces of candy contains 24 calories. So what is that 24, 5 or is that 5, 24? Yes, because what's happening here is you are inputting how much candy you eat, and what's coming out? Calories. The number of calories you consume depends on how many pieces of candy you eat. The more candy you eat, the more calories you're going to get. Does that make sense? So now, how does slope work on a direct variation? 24 minus 0 is 24. 5 minus 0 is 5. The slope is 24/5. It's just y over x for these kinds of lines. Which one is showing this slope getting multiplied by x? Yes. Now, what did they... This was tricky because they had never done this before. Usually when I write the equation of a line, I like to try to make the x look like it's out to the side. They decided to insert the x into the fraction. When they put it into the fraction, it has to go on top, or it's not a linear situation anymore. Also, you could have done this. You would have to have known that 524 was the point you were looking for. You could put this into y equals, and guess what you should see in the t-chart? 524. If I put a 5 in for x, look what happens. What happens to multiplying by 5 and dividing by 5? They cancel out. If I put in 5 pieces of candy, look how many calories I'm left with. 24. Okay, now that's direct variation. Whole different ball game with indirect or inverse variation. So this is the new stuff. Inverse variation. Oh, real quick before we get to inverse. Is this direct or not? Why not? Doesn't go through the origin. Is this direct? Yes, it's linear and it goes through the origin. Is this direct? No, why not? It's not. Okay, it's not linear. It is going through 0, 0. Going through just means it's there. Is 0, 0 on that graph? Yes. Is it linear? No. Is it direct variation then? No. Direct variation is linear. Is this direct? No. Why not? Because the y-intercept is not a 0. So this is no. What about this? That's a parabola. What is direct variation? Linear. Is this? Yes. Is this? Can't be 100% sure, but I know if I solve this for y, is that going to make this a 0? No, the y-intercept is not going to be 0. What about this? Yeah, the y-intercept will be 0 here. Okay, now, new topic, folks. Please get quiet. We got to get through this, and I want you to have time to work on your homework. Hush. Inverse variation or indirect variation. It is not linear. And this is the one kind of function that we have ever done where x is in the denominator. We have never done a function where x is in the denominator. In indirect variation or inverse variation, this is the one time where x has to be in the bottom of the fraction. And it does not look like a line when you graph it. Some things that are similar, you only need 1 point to find the whole equation. That's really kind of where the similarities end. In direct variation, as one thing goes up, the other also goes up. But in inverse variation, one part will go up and the other will go down. Now, inverse variation looks like this. It's a curve, and it's shown in 2 different quadrants. It really has, I've never seen them ask about asymptotes on inverse variation. It really has 2 asymptotes. But the ones that we're going to deal with usually are attached to some kind of real life situation, and they usually only show you the part that's in the first quadrant, the positive inputs and outputs. But I want you to realize it's not linear. X is in the denominator, and that's pretty much where the similarities end. I'm going to show you. That means your input is actually under a division bar, because x is what you put into a function, right? The parent function looks like this: y equals 1 over x. See the difference? In your calculator, let's look at that. That's an inverse variation situation. How do I know? Because x is in the denominator. So everybody go to Zoom 6 and let's look at this thing. We're looking at the parent function of y equals 1 divided by x. That's the parent function for all inverse variations. It's going like, it's in the first and third quadrant. Yes. Okay, now let's look at some problems. Folks, stay with me here. Let me just tell you, in the past 2 or 3 years, I've seen several direct variation problems, and the questions kind of go in cycles. So I didn't see any indirect variation on the last 2 years, but that means I'm expecting to see one this year. So you better make sure you listen. How do I know this is indirect or inverse variation? Because it says it right here. So that's, when you see that, that's your first clue. You should be picturing, oh, there's going to be an x on the bottom somehow, some way. Are you with me, Oscar? Okay, now, also, when one thing goes up, the other goes down. Look at what's happening here. What do you think it means that the time it takes is varying inversely with the number of people working? If there's more people doing the work, what happens to how long it's going to take to get the job done? Less time. The more people that are helping do the work, the less time it's going to take to do the job. Do you understand what I'm saying? 2 people on a construction site building a house is going to take forever. 20 people, the time to build the house is going to go down. Are y'all listening? Okay, now, this another weird thing about this. Remember when we were doing functions and I told you if time is involved, usually if time's involved, it's independent? That's not the case here. What depends on what here? The time it takes to do the job depends on how many people are working. So you're inputting number of workers, and what you're getting back is time to do the job. And this is also the first time we've ever looked at a function where time was dependent instead of independent. So in the 1 point they gave me, what order would I put it in? Is it 15:6 or 6:15? 6, 15. Oscar? That's all I need to write this equation. That's all I need to write this equation. Now, normally on a linear problem, we find slope. This is not a linear problem. This is so much easier to find the value of k. In this case, to find the value of k, which is kind of like slope, but it's really not because this isn't linear, all you've got to do is multiply your x and y value together. Super, super easy, because you don't have to worry about which one goes on top and which one goes on bottom. You just multiply them. So what's the value of k here? 90. What's 6 times 15? 90. Okay, now I can write the equation. It's y equals 90 divided by x. That's the equation. What comes out is the time it takes to do the job. What am I putting in? Workers. So if I put in 6 workers, how long is it going to take to do the job? 15 hours, because 90 divided by 6 equals 15. What if I increased it to 9 workers? It's going to take 10 hours. So that's another point that's on the graph. If I put a 9 in, I'm going to get back 10. What if I increase it to 10 workers? 9 hours. So I'm taking that K value that I found by just taking the 1 point they gave me and multiplying the X and Y together. It's so much easier than finding slope. Okay, let's look at some questions that I've seen on the... Oh, well, this one wasn't on the STAR test, but we're going to do one in a second that was actually on the STAR test. And they love to throw situations out there that you've probably never dealt with. You've never bought houses. You've never had to worry about percentage that the house increases. You might not know what this even means. You just kind of read through it and see if you can figure out what they're saying. What do you think is independent here? The string. You're inputting how long the string is, and that's affecting the frequency. So you're inputting string length, and that's affecting the frequency. So look at the point they gave me. What am I putting in? 40. What am I getting back? 60. So the point they gave me should be in this order, 40, 60. What's my K value? 2,400. You just multiply those two. So what's the equation then? Y equals 2,400 over X. That's my equation. If I put in a 40 centimeter string, 2,400 divided by 40 would give me a frequency of 60. Okay, now, here was the one... Oh, wait, before we get to that question. Inverse variation, yes or no? Okay. Okay, first of all, inverse variation is not linear. This is linear. How do I know it's linear? It is constant. Now, I skipped some X values. 2 was 6, 3 was 9. Do you see how I skipped 4 and 5? But it's going up by 3. So if I wrote in the 4, it would be 12, then 15, and the 6 would be 18. This is constant. That means it's linear. Inverse variation is not linear. So no, this isn't. The second one is y equals x squared. They're squaring the x value. Is that inverse variation? No. Here's another way you can check. Check the k. The k value should be the same for every single set of points. What's 2 times 4? 8. What's 3 times 9? Oh my gosh. Do these have the same K value? No. Now look at this. What's 2 times 30? 60. What's 3 times 20? 60. What's 10 times 6? Do you see how the K value stays consistent? This is inverse variation, indirect variation. Yeah. If you multiply your x and y and get the same amount every single time, then that is inverse variation. This is a parabola, and this is a line. This one is inverse variation. Okay, now, check out this problem. You might see this problem later on. Oscar, wake up. Whatever y'all got to do to wake yourself up, do it. Folks, I'm not amused. Hold on. We'll go back to what? I don't know that you can... Yeah. The equation here would be y equals 60 over x. Yes. No. Okay, do this problem, please. This was the question that was on the end of course exam about 3 or 4 years ago. So this is what I'm thinking, is that they're going to put something like it on there this year. Okay. How do you know it's inverse variation? It says it. So the answer choices were a bunch of equations. They wanted you to find the equation. It should be super easy for you to find the K value. Use your calculator. What's the K value? What? 1800. How did she find that? 50 times 36. So then the equation would be y equals 1800 divided by x. Now, they did not have that down there. They had this choice, and they had this choice. Only one of them is correct. Which one? So they also they made you determine whether force depends on distance or distance depends on force. Okay, this was the one right here. What it's saying is, and they had a nice little picture to go with this. They had a rock they were trying to move, and it's saying that how far you are away from the pivot point will determine how much strength you've got to use to push down on the rock. So the force you need to exert depends on the distance you are from the pivot point. Now, here's a clue that it was this one. Do you see? And I don't know if they would do this again, but do you see how this one was capitalized? Yeah, you were trying to find the force needed, and you were inputting the distance from the pivot. So, but at least on this one, you could have eliminated it down to 2 choices. Okay, we will come back to that and do some more with that, but as for the rest of this period, you're going to work on, still on this 2013 test, you're going to do a section from the middle, and it's homework. I'm going to give you the rest of the period to work on it. Bring it completed, no cheating, no guessing, no incomplete tomorrow.